All right, so we're looking at example 6a, and we want to determine the equation of the line whose graph is parallel to the graph of 2x minus 3y equals 7. And it passes through the point -6, -2. So parallel. Keep in mind that a parallel line is a line that has the same slope. Okay, so we're dealing with parallel and perpendicular lines with example 6. Our next example will deal with perpendicular lines. So what we want to do with parallel lines is determine the slope of this equation. So we know that it's parallel to this equation, so that means we need to find the slope of this equation, and that will help us determine the slope of our line that we're trying to find. Then we also know that the line passes through this point right here. So the line that we're trying to find passes through -6, -2. And then also we can determine what the slope of our line is by determining the slope of this line. So if we know the slope and we know the point, then we can use the point slope form. So that's just taking you through the process here. So first is find the slope. So let's find the slope here. So keep in mind, I'll just write this down here. Parallel tells us same slope. Okay, so we have 2x minus 3y equals 7, and we want to find the slope of this line. So what we need to do is we need to put it, let's go ahead and put it in the slope intercept form, which is y equals mx plus b, and we'll be in good shape. All right, so what we want to do is get y by itself on the left side of the equation. So we want to bring the 2x over to this side, and we're left with -3y equals -2x plus 7. Now we want to divide by -3 to get that -3 on this side, because we just want the y by itself. And we get y equals -2/3 divided by -3. Or sorry, -2 divided by -3 is 2/3. So that's 2/3 x, and then -7/3. But we really don't care about the -7/3. All we really care about is the slope. So we know the slope is equal to 2/3. Okay, so now we're ready to move on to the next part, which is using the slope that we've derived. That's the slope of this line, but since we know the line we're trying to find is parallel to this line, we know that the slope of the line we're trying to find is also 2/3. So we know that that this point also goes through our line. So we're going to use this slope and this point to find our equation. So we want to use the point slope form. So that being y minus, y1. Y minus y1 equals mx minus x1. We used this before in the previous slide, and we're going to use it again here. All right, we have y minus y1, so y1 is the -2. So keep in mind we're subtracting y minus y1, so y minus -2. Get a little tricky with the signs, but realize we're subtracting a negative number because our y1 is negative. M is 2/3, and then x, that is that's just x, that's our variable, a minus, and again we're subtracting a negative number. And there we go. And this gives us plus, so we have y plus 2 equals 2/3 x. Similarly, we have plus 6. Now we want to distribute the 2/3 through the parentheses. So we have y plus 2 equals 2/3 x. 2/3 times 6. We'll do that over on the side here. 2/3 times 6 over 1. And we can reduce to this. So that's 2 times 2 is equal to 4 divided by 1 times 1 is 1. So it's just 4. So it's plus 4. 2/3 times 6 is 4. And now we need to subtract the 2 to cancel out the 2 on the left side of the equation. And finally, we get y equals 2/3 x plus 2. And there's our equation. Now, again, just to recap what we did, I mean, what this is telling us is, notice that we have the same slope. Here's our other line in slope intercept form. Y equals 2/3 x minus 7/3. Notice that we have the same slope, so it's parallel. But based on using x1, y1, this point right here, we know that this line is going to contain, if we were to graph this, we'll notice that -6, -2 would be contained on this line. So that's what we want. We want it parallel to this, but going through this line. All right, let me know if you have any concerns. I'll be more than happy to help.